Okay, so welcome back. So now we are going to write a code for the pre-order. So there are two approaches to write this. One, I can use the recursion, and one is the iterative approach. I normally prefer to do anything with the iterative first, because iterative give you a very basic understanding like how the code is moving. Because recursion is behind the scene, you have to understand. From the code you cannot understand the flow. You have to draw some picture, some mind game is there. Okay, so first I will try to with the iterative, because iterative is in the core it's iterative only when recursion is going to run. So let's focus on the iterative approach first. All right, so this is the class that I am going to reuse. I have created in the last lectures. So one tree node is there. This is structure of any tree and is having left node and right node. Fine. Okay, so now what I'm going to do now, let me create one class, iterative pre-order. Okay, I created this class now, and in this I'm going to create one static method, right? Static, there is nothing to return in this, and pre-order, and this I'm going to pass the tree node that is root. All right, so okay, so if you remember, whenever is starting the pre-order, what are we doing? First we are printing or reading the root node. After that, immediately I need my left node, then right node, then again tree node, I mean root node, then again left and right for each subtree. Okay, so it means when we are reading the data or reading the node, at that time the order should be maintained. Means once we are reading the root, after that the element that we are going to read next should be always left. Fine. So there must be some data structure we have to choose which can always give you the last added element on top. Hope you guessed that. So we are going to use stack in this, right? Okay, before that, first check normal check if root should not be null. If this is equal to null, then I'm going to return nothing, right? Now I'm going to create a stack, and stack is having tree node, right? Tree node, and this is nothing but a stack that equal to new stack, right? All right, and first element is always root, so whenever you are doing the pre-order, root must be printed at first. So I'm going to push by default root, correct? Okay, after that I have to keep reading this stack and keep printing on the top element, right? So while I have to check if while stack dot is empty is not true, it means some data is there, so I have to simply pop that. So tree node, this is a current element which I am printing, right? It should be stack dot pop, right? Now till this line, till 18, your stack is now empty. So how will you read next in the while loop? You have to add the left of this stack current element and then right. Fine, but again there is a point to understand here. If you are going to add left first then right, then stack, how the stack will going to behave? When you're going to pop the element, it is going to give you the right side children, right? So our order is going to be broken, right? Because I need left one. So it means I have to, while adding, I have to do the reverse. First I have to add right, then I have to add left, so that while popping I will get the left element. Hope this makes sense. Okay, so current I already got it, so let me print this, because reading means I am printing here. So current dot get current dot val, right? And I'm going to give some space here so that next element will be printed with some space. Fine. And line change is not required because I need a contiguous kind of array, right? Okay, so now I'm going to add the right first here. You remember why, right? I already just told you, if your current dot right is present, then I'm going to push data in my stack dot push current dot right. Again, if left is present, then I'm going to push left also. If current dot left is not equal to null, then also I'm going to push now. So stack dot push current dot left. Now what will happen in this when I change the sequence? Now when your stack is going to be popped, which element will first pop? Left. And what do you want? You want left only, right? So that's why I have changed this. So here right element first, then left element first. Got it? So that much code only you have to write, and every time I'm popping, I'm writing that. So let me write one now main method, nothing to return, so this method is going to be closed here. Let me write main method now. In main method, what I'm going to do, I am just going to create some data. So tree node, let me copy from here. I think I have the main method, right? Let me write this. I think this should also run. Okay, so how this should be print? First 10 will be print because it's the root, then left element, that is 5, then again left, right, 2. So let's see that how this is going to be printed. I'm running this now. Some error came, let me check. Oh, I have added, but I am not calling the method, sorry. So PreOrder I have to call here, right? So PreOrder and root I have to pass. Actually it was copied from this code, said that here I am not printing anything, so I missed that. Anyways, so let me run that now. So first element is going to read 5, this one, okay, then again this left is 2, then 2 will come. After that, is there any 3 left? No. Then I'm going to print right, correct? So 2, after 2 the 7 will come. Is there any 7 is having root, any right is there? Yes, right is there, 14. So I'm going to print the 14 now. So once you draw this one tree structure based on this, you'll see the difference, like how this is happening. Okay, so this is for the PreOrder iterative approach. If you see how we are doing the same operation again and again, because now I want to convert this code into a recursive way. Okay, so let's find out that intuition from where this come. So to understand this, first you have to understand why we are using or why you are needing stack. Because after going left, understand, because after going left I need a way to come back later, because when I'm going left, then again we are coming towards the root, you are going in the reverse direction, right? So it means somewhere you have to store this, like what you have visited, and that's why stack is coming in picture. Stack is helping us. Okay, so stack is remembering that. Okay, so if you see carefully, recursion is not a magic. It's recursion also uses the stack internally. And let me again find out like what actually we are doing in this, just a general term. So what I'm doing, first I am processing my current node, means I am printing that, right? Then what I'm going to doing, I'm simply going to left, adding that, then I'm going to right, I'm adding that. These 3 steps I'm doing. Okay, so if I convert this like this way, first I'm saying visit current, right, then traverse to my left, current left, right, then traverse to my right, correct. These are the 3 steps I'm doing, and this sentence itself become a recursion because every while you are doing this same. Okay, so what I have to do here now, we are going to replace this manual stack with function call. Okay, so how do we change that? This line is okay, I mean this validation is okay, this is required in that case also. Now after that, what I have to do, I am printing that is also okay, this one. So I have to print that, then I have to add the left, then I have to add the right simply, correct. So the final code will become, let me write this method again, let me write here one more method, static void PreOrder recursive, right, and I'm going to pass in the root tree node root, correct. So first condition is same, I'm going to copy this is required because this is the breaking condition, because in recursion if you don't have any breaking rule, it will go infinitely and it is going to hamper your system, everything will freeze. Okay, I'm going to return. Now what I have to do, I have to process my element, right. Processing means I'm going to printing this, right. This is my processing in this case, because I'm reading this, I'm just reading, so I'm just copying that now, and this will become root dot value, correct. Now I have to add left, then I have to add right. So what I'm going to do now, I am going to add this. So PreOrder, same method I'm going to call this recursive, right. So I'm going to call this method again with its left, root dot left. Once this is closed, then again I'm going to call the same method with root dot right. Alright, that's it. So this whole program now is going to be changed in this 4 line. See, so this is the beauty of recursion. Understood? If I going to call this method, let me comment this out, let me keep this. Let me run this now, both answer will be same, right. Okay, let me add one here, one line, so that it will be easy to differentiate. Okay, so see, both are same, na? Yeah. So this is the beauty of recursion, it reduces the code by many folds. Okay, now I'm going to draw a recursive tree for this. Recursive tree is a term because why I'm going to do, how this stack is now behind the scene, how this execution is going on. This is not necessary to understand, but it's required when you are going to explain something. Okay, and it's a kind of virtual picture that you have to keep in your mind while doing any recursion. Okay, because recursion, there is nothing in recursion problem is that there is no much debugging scope. So if something wrong is happening, it's very difficult to identify. So that's why you have to understand this picture, how this run actually. Okay, so let's do that. So example is 1 2 3 4 5, right? Let me draw a recursive call tree. So first I'm going to start from here, root. So my pre-order will be called here. Okay, I'm going to call my pre-order recursive method with 1, right? And what it is going to do, it is going to print, and that is going to print 1, right? Then again I'm calling my pre-order method, right? Again I'm going to call pre-order in the same line, and in this now I'm going to pass 2. What this is going to do now, this is again going to call the print, this method is again going to repeat, right? Now it's going to print 2. After that again I'm calling my pre-order method, right? And pre-order, what I'm going to do, I'm going to take 4, right? Because left I'm doing, right? So this is left is going on, this parallel is going on. Okay, once again pre-order is coming, then again I'm going to print something, right? Print 4. Now once 4 is done, what I'm going to do now, my this is over, because pre-order is having, if I'm going to call the pre-order here, what is the left of pre? That is null, right? So I'm going to pass here null, my loop will be broken, right? It's going to be return. So it will return means it will go on the this way. Again this is going to return here, then this is going to return here, like that it will went on, right? But once I leave the 4 here, I'm not going, let me just one mistake, let me remove this. Okay, so I'm here now. So now what is left, there is another pre-order, that is when we're going to add a write element. Okay, so again at the same level of pre-order 4, I am now going to call here pre-order 5, right? Again I'm going to print, and once I again, then I'm going to check, is there any left? Do you have left? Sorry. So I'm going to pass in this null, it's null, so it is going to be returned, right? It will return, it will come here. So pre-order left is called, now I'm going to call right. Do you have anything on right? That is also null, right? Let me write all the nulls here so that it will be considered. Okay, so 5 is done now. 5 left is null, nothing is going to happen. Then again I'm going to check, okay, let me check pre-order right is also null. Again this is going to return, right? So in this way my this got processed, this tree is processed now. Okay, this is also. Now coming to left is done. Now I'm going to node, right? Not node, I will go pre-order, right? Node is already done here, sorry. So now I'm going to write. So let's go to the write now. So write will go at this level. See, one left I was processing here on this part, all these were left part, right? All these were left part. So now I'm going to, in parallel, now I'm going to call the pre-order with 3, that is the right part. Okay, so again I'm going to print 3, process done. Again I'll check if there any left element is there of that, then pre-order 3 dot left is null, so I'm going to pass null. Again it will return, and after that again pre-order I'm going to check right one, that is also null, and this is going to return. So we whatever you draw here, this is called recursive stack tree. Okay, so our final output would be how all the print statement will be there. So one first print statement, then 2, then 4, then 5, correct, then 3. So this is the pre-order traversal of this. Okay, so every box is a separate function call, remember that, and we are going to store this in the JVM stack. Okay, so if I just draw a visual stack movement how it is happening just for clarity. So my in step 1, what is happening, I'm calling this method pre-order 1, right? Let me write here stack also. So in my stack internally, I mean JVM stack, I am pushing 1, correct. This is what is doing, it's internal function, we are not writing the code for this. This is happening in the JVM. Now in step 2, what is happening, I'm going to call pre-order 2, correct. So now my step will be having 1, 2. Then I'm going to call step 3 and I'm going to call pre-order 4. So I'm going to call 1, 2, 4, right. Now on the step 4, what is happening, now left and right of 4 is null, right. So what I'm going to pop return. Okay, I'm going to pop. So which one will pop, this one will be 4 will be popped. So my stack will be now having 1, 2. Now JVM resume exactly where it paused, right. After that again this process will start again, it will go to the same point where it was paused earlier, right. So if you see here, I mean if you try to generate some analogy based on this, then a stack trace. So you are pausing a movie and watch another movie, then resume the previous movie. So you are jumping from one movie to another movie, you are finishing that, then you are coming back and resuming from where it was paused. Understood? So one movie was doing, you paused it, you came to another screen, you start some movie, again you switched your mind and again you started one more movie. So once this is finished, you come back, you'll finish this, then again you come back, then finish this. So this is the same pattern is happening. All right, so every recursive call creates a new mini word simply. Okay, why I'm saying this statement, because every tree, every subtree is actually a tree, full-fledged tree, right. The only thing is that its root is connected with some left and right reference. That's the only difference, right. So it's having its own root, it's having own execution. Every stack will have their own root, own execution, own pending work. Okay, so recursive tree was talking, so it will be like that: pre-order 1, that is pre-order, I'm going to left 2, then I'm going to pre-order 4. Okay, it's done. Then I'm coming to pre-order 5, correct. Then I'm coming back because everything is done. I'm coming here now, I'm going to call pre-order 3, right. So this is called recursive tree. Right. So I just want to show you this because it's very necessary. Okay, so since you understood, so now onwards whenever we're going to write any program for tree, we are going to call most probably recursive function only. Okay, so look, what we're doing recursive, we're going to write in iterative. Sometimes it's become very complex, so that's why we avoid those and always try to follow, especially in the tree structure, recursion. Okay, so let me now so I'm done with this explanation. Now next is left what, Inorder and Postorder, right, and then BFS, correct. So let me try to complete this in the next video then. Okay, let's see you in the next one.